example 7a, we're writing a function in terms of u. This one's going to seem harder, I think, because there aren't any numbers. But it could be easier because there aren't any numbers. It's just going to depend on your attitude, I suppose. But again, we look at this and understand that that's an angle. Okay, so you can call that a or theta or whatever. We're going to have sine theta at some point. But what I want to do is I want to draw a picture of that angle. Draw a picture of angle theta. Now, the thing that's tricky about this is we know that tangent theta is defined, or its range is from negative pi over 2 to positive pi over 2, which puts us in either quadrant 1 or 4. Now, because that u is a variable, I don't know at this point if u is positive or negative. So really, we don't really know if that's in the first or fourth quadrant, but it turns out that it doesn't matter because it's a variable. It's gonna work out the same either way. So let's just draw it in the first quadrant. Okay. And so if you think about it, it doesn't matter that we don't have numbers. It doesn't matter. You've got the tangent ratio is u over 1. And so we know tangent is y over x. So let's draw our picture. We want to draw a picture of theta in the first quadrant. Okay, this will also work if you draw it in the fourth quadrant, but I'm going to draw it in the first quadrant. The tangent ratio y over x is u over 1. So let's just do u over 1 right there. There's my y over my x. And then we have to do Pythagorean theorem to find that missing side. So a squared plus b squared equals c squared, or r squared if you want. And so, what I've got is u squared plus 1 equals c squared. In order to solve, I'm going to take the square root of that. C is going to equal the plus or minus square root of u squared plus 1. I know that's an ugly looking expression, but that's what we've got. And so since the radius here, or the hypotenuse, will never be a negative number, we just know that's going to be just regular square root of u squared plus 1. That's your hypotenuse. Square root of u squared plus 1. And so I've done the hard part. All you have to do is find the sine ratio. We're finding sine theta, and so sine theta is y over r. So look at your picture. Look at your angle theta, and the ratio for y over r is u over square root of u squared plus 1. That's y over r. That's the sine ratio. And so we do what we always do. We rationalize the denominator. And that gets me this big old mess up on the top. U times the square root of u squared plus 1. On the bottom, the square root goes away. You can combine those. You get just regular u squared plus 1. And that's it. So maybe that's easier than having numbers. We didn't have to do a whole bunch of algebra and stuff with the numbers. So let's look at 7b. It's pretty much the same thing. Okay, we're writing an expression in terms of u. But again, look at your inverse trig function here and understand that that's an angle. You call it a or theta or whatever, it doesn't really matter. If you understand that that part is an angle, you're going to recognize cosine 2a, which would force you to look at your formulas probably. I don't know if you know these or not, but that's a double angle cosine. And so you look at your double angle cosine identities, and you see that there are three different possibilities. So we're going to have to pick one, but let's hold off on that. We'll pick one later. Let's draw a picture of angle A. Again, for inverse sine is defined, or its range is from negative pi over 2 to positive pi over 2. Again, that puts us in either quadrant 1 or quadrant 4. And it'll work for either one, but let's just stick to quadrant 1. I'm going to draw my picture in quadrant 1. And so we're drawing a picture of our angle A, label it, in quadrant 1. Now notice what we have. We have the sine ratio. Inverse sine is u, so we'll call that u over 1. But my sine ratio is u over 1. So that's the y side over the r side, right? Y over r is u over 1. And so again, I'm going to do Pythagorean. You go like x squared plus u squared equals 1 squared. Subtract u squared over, you'll have x squared equals 1 minus u squared. And then take the square root. X is going to equal plus or minus square root of 1 minus u squared. But since we're in the first quadrant, we'll use the positive version. And so this missing side, this x side, is the square root of 1 minus u squared. Okay. So I'm finding the cosine ratio. Okay, I'm finding the cosine ratio. So let's look at one of my 3 double angle identities. Maybe we use 1 minus 2 sine squared A. Okay, I just picked one. If you look at that, that's 1 minus 2 times the sine ratio squared. Okay, it turns out that this was easier than I even made it, because you could have told me the sine ratio without drawing this picture. Okay, look at the picture and tell me what the sine ratio is. It's u over 1, right? It's u over 1, but maybe we could have told that, just from looking at the problem. The sine ratio is u over 1, of course it is. Okay? And so what I have then is 1 minus 2 u squared. That's it.